when we're live, John.
Okay. Okay, we're about to hear the voice now, and then we'll be live.
The broadcast is now starting. All attendees are in listen-only mode.
Welcome, everyone. This is Michael Drew with the National Renewable Energy Laboratory, and this is Better Building DOE Better Buildings Alliance peer exchange for ventilation setbacks for healthcare facilities. We have 3 great panelists today lined up, and we will be starting here shortly. So all attendees are in listen-only mode. But if you do have questions, please type them into the chat box, and we will be getting to those at the end of the presentations. Please advance to the next slide, please. So I wanted to, here's the agenda today. We're going to have a short welcome and introduction of the speakers, and then we'll have these 3 speakers in these areas talking about ventilation requirements and ASHRAE standards, and then we'll have 2 panelists speaking about what they've done at their healthcare facilities, how to get buy-in for air exchange setbacks in operating rooms, and then in New York from Cleveland Clinics and the New York Presbyterian Hospital to talk about their experience and how they've implemented their HVAC setbacks and what their plans are for the futures. And then we'll wrap it up with a Q&A session at the end. So go to the next slide, please. So our 3 speakers today, Jeff Bolt from KJWW Engineering. He's the Director of Engineering there. He's very active within the ASHRAE standards committees with 90.1, 189.1, and a consultant to ASHRAE 62.1, and also contributing author for the Advanced Energy Design Guides for large hospital and small healthcare facilities. And then we have Paul Slobodnik from Cleveland Clinic. He's the Director of Facilities Management there, and is going to be talking about their efforts at Cleveland Clinic. And then finally, we have Roberto Nunez from New York Presbyterian Hospitals, and he is the Director of Facilities Operations there. So again, if you do have questions for the speakers as you're listening to them, please type them into the chat box, and we will get to those at the end of this session here. So I'm going to pass it over to Jeff and let him take it from here.
Okay. So next slide. Okay, go ahead. Next slide also. So just the codes that we tend to see for a lot of healthcare facilities, we see a fair amount of FGI 2010 setting the ventilation requirements. Probably we'll start to see 2014 being adopted by jurisdictions soon. I haven't seen it yet in any facility I'm working at. Also, ASHRAE 170 is brought along by FGI, and we see a lot of 170, 2008, and soon we'll probably see 2013, which is referenced in the 2014 FGI guidelines. Also for the non-healthcare areas, most of the country is governed by ASHRAE 62.1 through adoption of the International Mechanical Code. So we see a lot of that. Obviously, if you're in California, both of those will probably be different. And individual states often in healthcare have their own regulations. For example, I do a lot of work in the Midwest. I live in Wisconsin, so Iowa adopts FGI 2010, including the ventilation stuff. Wisconsin adopts only the ventilation stuff of FGI 2010. Illinois has their own Illinois Department of Public Health, and probably some people on the line are from California where they have different regulations because of OSHPD. Next slide. So I'm going to do a couple of examples out of ASHRAE 170. For example, in a patient room, the requirement in 170-2008 is for 6 air changes total and 2 air changes of outside air. One thing I want to clarify about that in standard 170, which is different than a standard like 62.1, is that in standard 170, you can add up the outside air requirements for each room, total them, And if you bring that much in at the air handler, you're good. So just because a patient room requires 6 total air changes and 2 air changes of outside air, this does not mean your air handler has to be at least 33% outside air. I sometimes call that the California rule because the rest of us have to deal with 62.1 and the multiple spaces equations, whereas the lucky dogs in California can just add up the outside air and bring it in at the air handler. One other item in Standard 170 is that in 2013, for patient rooms, it reduces the total air changes to 4, which can be a significant energy savings. So maybe if you can talk your local code authority into letting you step up to the newest code, you might be able to save some energy. Also, I think the wording could be a little more clear, but my reading of the wording in Standard 170 is that an unoccupied patient room has no requirement for air changes. The actual wording says that pressurized spaces can be set back to the minimum required to maintain the required pressure relationship, and it doesn't quite mention spaces that don't have a pressure relationship, but I think it's pretty well implied that it means there isn't a requirement. And just, I'm not a guy who designs in California at this point, but my quick reading of the OSHPD requirements is they would allow reduction to 25% of flow when a patient room is unoccupied. Next slide. So for an operating room, the requirement is for 20 total air changes when occupied. In unoccupied, the only requirement is to maintain the pressure relationship, which, depending on how airtight your operating room is, may take a couple hundred CFM, could take as much as 1,000 based on some anecdotal things we've heard from people who have done blower door testing in operating rooms. It can have a huge impact on energy use, especially, I put up a graphic here of the Advanced Energy Design Guide for small hospitals and healthcare facilities. In that guide, when we added the recommendation that ORs set back, and I think we picked 4 air changes as being enough to maintain the pressure in that case. It took us from being a 30% savings guide to making over 40% savings in every climate zone except Alaska. So it has a huge impact on the energy use of those spaces. My quick reading of the OSHPD regulation is that they would let you go down to 6 air changes. Now, you do want to be safe. I mean, the biggest reluctance we see to people doing this is that they're afraid somebody will forget to put it into occupied mode. And we've seen things like you've got a switch that overrides it to occupied. You've got a time of day schedule that also overrides it to occupied. If a procedure light is on, it goes to occupied. If the general lights are on, it goes to occupied. So that if any of those kick in, that you're in the occupied mode. Next slide, please. So another thing, at least during design, that you have some control over is ceiling heights. I mean, everybody loves a tall ceiling and nice daylight and views and so forth, but our ventilation requirements are usually, in most codes, based on air changes. So just for a code minimum 150 square foot patient room with an 8-foot ceiling, I do an example saying that requires 120 CFM of flow, whereas with a 9.5-foot ceiling, it's 143 CFM. And often that air is being cooled to dehumidify it, plus it's being reheated to avoid overcooling the room, depending on what time of year it is. So it can affect your energy use. Also in a new facility, if you choose to do displacement ventilation, Standard 170 only counts the 6 feet of the height into the volume, which could lower you in this case to 90 CFM. Do note, however, that stayed at 6 air changes and 6 foot in height in the 2013 version. So actually with an 8-foot ceiling and 4 air changes, if you're on the newest version of the code, you'd actually get a little below that, down to 80 CFM. I've never quite understood why these are done on an air change basis. To me, having a taller ceiling doesn't add contamination to the room. I'd prefer some of these things be done on a square foot basis, but I don't write all the codes. So next slide, please. So one thing I wanted to point out is that sometimes it's not just that you may reduce the flow, it's that you must reduce the flow. If you're in an area where IECC 2012 or newer, or ASHRAE 90.1 2010 or newer is your energy code. It is actually required that you do that because of if you're reheating the air, which is normally the case in healthcare. There are really only 4 exceptions left that allow you to reheat air, and the only one that applies to most healthcare spaces is exception number 4, which is the airflow rate required to comply with applicable codes or accreditation standards, such as pressure relationships or minimum air changes. And I'll do a couple examples of that. Next slide, please. So here's an example in a patient room. So I chose a 9-foot ceiling and a code minimum 150 square foot room in this case. So I have 135 CFM minimum flow that I have to maintain. And let's say my cooling load on the peak day is 250 CFM. So what that really says is I can only reheat 135 CFM by ASHRAE 90.1 or IECC 2012. So that means I am a VAV system. I mean, that change to the reheat requirements basically made constant volume hospitals not in compliance with code in areas that use those energy codes. So next slide, please. And I did another example with an operating room. Let's say you have a 400 square foot OR with a 10-foot ceiling, 20 air change requirement under ASHRAE 170 or FGI. So you've got about 1,300 CFM when you're occupied. Unoccupied, the only requirement is to maintain 0.01 inches. And in my example, I picked 400 CFM as what was required to satisfy the pressure controller. Yours may be higher or lower. But again, 90.1 and the IECC only permit reheating that 400 CFM when the space is unoccupied. So from a code standpoint, it's actually required in those energy codes. Again, it makes it a VAV system. Next slide, please. Another option, at least if you're doing a new building, is dedicated outside air. The biggest savings there is avoiding reheat. I included the pie graph there for a typical VAV reheat hospital. It's even worse if it's a constant volume facility, where reheat is typically the biggest piece of the pie. And the picture I've got in the lower left there is a Great River Medical Center in Burlington, Iowa. And one of the things with the DOAS, that's actually a geothermal heat pump with DOAS. But one of the biggest savings is that a lot of times, in Iowa it's kind of cold, and you've got a little heat being generated by the lights and the patient and maybe a piece or two of equipment and a TV, and you've got cold coming from the outside window and the wall, and you're kind of in temperature balance. So the only thing that's happening is you're ventilating and the fan is running in your heat pump, but the compressor isn't necessarily running very often. And I believe that facility is Energy Star 100, and the last I heard was somewhere below 100 kBTU per square foot per year. And I would say the bulk of those savings are because of the DOAS plus heat pumps. When we did the Advanced Energy Design Guide for large hospitals, we included a system similar to that, except without the pond, because for those of you that live in urban areas, it's kind of expensive to buy all your neighbors' buildings and knock them down and build a pond. But you still got most of the savings from that type of system. Next slide, please. So also for your non-healthcare spaces, demand-controlled ventilation can save quite a bit of energy. It's becoming required for a lot of these spaces more and more in the newer energy codes, but your conference rooms, your dining rooms, your lecture halls, normally this is not your spaces that are regulated by standard 170 or the FGI. In multiple zone systems, the math can get kind of complex, except I think if you're in California, there's a rule about what parts per million you should set it at. Or if you're a single zone system, the math also gets pretty simple. But it can be a big energy saving feature. Next slide, please. So I'm just going to finish up with an item about surgical procedure lights. And at first you may think, well, what's this got to do with ventilation reset? Well, what we have found is that the traditional surgery lights are basically an incandescent style of fixture, a halogen, which is somewhat more efficient, but it still puts out the bulk of its energy as a beam of infrared heat, which is heating up the people in the operating theater. And because of that, they want to turn the thermostats down. And you have to maintain 60% maximum relative humidity. So if your surgeons are asking you to keep, 60 degrees instead of 65 degrees, or 63 instead of 68, that's a big energy issue, and much more of an HVAC energy than a lighting energy. Next slide, please. And here I just did a quick calculation of an operating room with 2 surgical lights being retrofitted to LED instead of quartz halogen. And we're showing in the end a savings of about 370 watts by changing to LEDs. But if the people using the operating room set the thermostat up, we've got 6,000 watts of HVAC savings from overcooling, having to overcool that air going into the space. So it can be a big deal, and especially for the facility that's having trouble, like the surgeons keep asking for it colder and you start missing that 60%, it can be a big deal for you. Next slide. I think that finishes me up, actually.
Hello, this is Paul. Next slide. Basically, I wanted to talk about the process that we did to obtain buy-in to get OR exchange setbacks at our hospitals. Next slide. So what's the big deal in getting approval? The first part, as Jeff alluded to, is from the surgical perspective, is safety. And that would be the impact on infection rates, hopefully not a negative impact. Also, again, as he mentioned, the surgical team wants to be comfortable, and so we need to keep that into account. From the administration and facility side, at least on our end, we've been tasked with cutting our utility consumption by $12 million in a run rate, not cumulative. And this OR setback is one of the largest single opportunities that we have. Also, it provides us an opportunity to standardize the OR look and feel, and we have 215 ORs in our enterprise. Next slide, please. So the first thing that we felt we had to do was figure out how we were going to control it so that we could present that to everyone with confidence that the system will always be in the right mode when we needed it. So with that, as Jeff also talked about, there are many different ways to activate it to go back to the occupied mode, whether it be a light switch on the pattern lights. We considered RFID tags on the patient so that when you rolled them in, it would sense that and kick up to 20. Occupancy sensors, so make sure that you have a redundant group of sensors that if anybody even twitched in the OR, it would pick that up and make sure that it maintains the 20 air changes. Also, a fixed schedule, which will work just fine in an ambulatory surgery center when all the cases basically start at 7 a.m. and the majority of them end at 3:30 or 4:30. You can just make sure that you put a buffer on the end of that and you'll be covered. Or looking at a flexible daily schedule. So in our particular case, when we looked at all of these, one of the regional hospitals actually did use the pattern lights to turn it to 20 air changes per hour, but that was until we were walking down a surgical corridor one day, noticed movement in a dark room, and found out that some of the eye cases were being done with the pattern lights off. So we had to change that. The RFID option doesn't address one of the things that infection prevention wanted us to address, and that was they said that they wanted it back to 20 air changes per hour as soon as the surgical team opened up the first surgical pack. And then on the occupancy sensors, as we did our investigation, we found that there are very few periods of time in the middle of the night that somebody's not in our ORs. We found that the terminal cleaning takes place in the middle of the night, that stocking by the anesthesia group takes place in the middle of the night, and then there's another stocking group that comes in and does the surgical supplies or the general supplies. So we saw at most a 3-hour period where there was nobody there. So what we're planning on doing is utilizing our surgical schedule and we'll look for the first case to take place, and we'll set it back to the 20 air changes per hour 30 minutes before that first case hits the room. And then we all know that the surgical schedule never really follows exactly the way it was planned, and so that there could be add-ons or cases taking longer than required or scheduled. And so we're looking at the schedule and saying, after that last scheduled case takes place, we're going to look for an indication that the surgical light is shut off to actually start it into the setback mode. And we'll add 45 minutes onto that to purge the room. Then you have the emergency situation where we had a concern, well, maybe emergent cases don't get put onto the schedule. And even though we've been assured that they all do, we felt that there should be an override and a user interface in those ORs. So we make sure that we did that. And then lastly, if they're still concerned about those emergent cases, you may have to set aside one of the rooms that they use for emergent cases and not put that on setback. Although that's not optimal, at least it gets you where you need to be, and maybe you can prove to them over time that the other system does work and convert that one as well. Next slide, please. So our next step was to obtain buy-in from infection prevention. And so in meeting with those folks, we shared that the existing conditions that we found weren't optimal as they are. While looking at the rooms after hours, we're finding that the pressure isn't always maintained. And when you investigate that further, you find that doors are propped open during those stocking periods. The other thing is the current in-room information isn't 100% accurate. Basically, we were using $50 peel and stick temperature and humidity sensors in the rooms that didn't jive with our building automation system. And also, currently we don't have all rooms with continuous air exchange rate monitors in them. We would rely on the annual balancers report to tell us that we were within compliance. And one of the things that we found out was our design team felt that if 20 air changes were good, then 25 is probably better. And then being facilities and cautious, they'll set it for 30. And as you get that balance report, you'll find rooms as high as 35. So we did some calculations and found out that if we set it back to the ASHRAE standard, we would save about $250,000 just on the main campus. The other thing that we wanted to present was this is not a new concept. We found out that in Washington State, as early as 1986, they were suggesting this as a standard practice, and that ASHRAE already recognized it as a best practice, and that other major healthcare systems are already doing it. And then lastly, reiterate to that team that the relative pressure relationships are always maintained during setback, as well as temperature and humidity. Next slide, please. So getting the buy-in from infection prevention and taking that buy-in or that recommendation to the Surgical Executive Committee was our first step. But the other thing is we wanted to present it in the light that this is not just an energy-saving measure, but it's going to improve the quality over what's already there. And it'll improve the quality by providing improved oversight, that they'll have continuous monitoring with alarms for all 4 of those critical variables, that they'll have that in the OR so that they would be able to see what those 4 variables are at all time, and that they would actually be consistent with that building automation system. And we have a web page set up that the surgical control desk will also be able to view all of their ORs and the 4 variables for all the ORs. And lastly, one of the big deals is that it would not require human intervention. They don't want to have to go throw a switch on the wall to put it into 20 air changes per hour, and they don't want to have to remember to turn it off when they're done. Lastly, we talked about the visible indication that if it's not at 20 air changes per hour, you'll see something red on that user interface to let you know. The other thing is if the system were for some reason to fail and start to set back into the 6 air change per hour, that it would give an audible alarm before it did that. And also if that last case for some reason was going on longer, they can always hit that button And again, that's a last-ditch, try not to have human interface required, but do that to override the system. And then lastly, we presented to provide an a prototype for them to see, to play with, and ask questions about. Next slide, please. So the present status is that setbacks have already been utilized in some of the regional hospitals, and they have been that way for a while. So we're just trying to get everybody doing the same thing, and that they would get upgraded with those in-room indicators. That infection prevention did, in fact, provide endorsement to the Surgical Exec Committee, and that the Surgical Executive Committee has agreed to move forward with us having prototypes installed in 2 ORs, but only being used to show the condition status at the present time, that our sequences have been written for the controls, and that we already have 2 ORs that are being recapitalized, and that we're putting the equipment in place. And lastly, the final approval of the funding to do all this work is being presented at our Finance Committee today. And with that approval, we're going back to the Surgical Exec Committee and asking for us to be able to turn the system on. And that concludes my section.
Good afternoon, everyone. My name is Roberto Nunez. I'm a site director at New York Presbyterian Hospital. I represent the Allen Hospital campus for New York Presbyterian. Please go to the next 2 slides. One more. So I'm going to be primarily focusing on controls, since I'm originally from the digital controls industry, which will be the main focus, and I'll be focusing on how we're utilizing the ventilation setback option at New York Presbyterian. It's one of the major contributing factors that has helped us achieve our energy savings and associated accolades from our partners in the industry. The Allen Hospital, which I currently work at, is responsible for approximately 300,000 square feet of acute care community hospital with approximately 200 licensed beds. We're just one of 8 healthcare facilities within New York Presbyterian healthcare system. As you can see within the slide, New York Presbyterian consists of 8 campuses, and it continues to grow, and with multiple ambulatory care off-site locations throughout the hospital. The enterprise is comprised of approximately 12 million square feet. So to put this in perspective, we are responsible for more than 4 times the square footage occupied by the Empire State Building. With 2,700 beds, over 21,000 employees, and we're a nonprofit organization. We are also the largest energy consumer in New York City, with a demand of approximately 40 megawatts. Our utility bill exceeds $50 million annually. So as you can see, this presents optimal opportunities for energy savings. This construction, New York Presbyterian is participating in many programs to help us achieve that. If you go to the next slide, you can see we're participating in many programs to help us facilitate that. New York Presbyterian is involved with the Department of Energy, Energy Star, Healthier Hospital Initiative, and more. Next slide, please. Because of these participations, we have been able to achieve many awards and recognitions. ASHI Energy to Care, Energy Star Partner of the Year for Sustained Excellence in Energy Management, Practice Green Health Environmental Excellence Awards for Energy Conservation, and many more. As most professionals in the industry know, energy costs consume over 30% of the healthcare facility's operational budgets. Ventilation requirements for critical care areas such as operating rooms are a large driver in these energy costs, as previously mentioned. Next slide, please. So in New York Presbyterian, we utilize the building management system to monitor and control ventilation, as most people utilize to take care of their building. The one thing that we have at a disadvantage compared to other places is that the ASHRAE standard will simply increase the air exchange requirements for operating rooms to 20. Unfortunately for us, New York City, the Department of Building requires operating rooms to operate at 25 air exchanges if a 100% outdoor air unit is not utilized. And because of the change in seasons, 100% outdoor air is not recommended if you're looking for energy savings. So today's presentation, I'm going to focus on the Allen Hospital and the building management features. And because we received Energy Star Certified Building Award in 2014, also previously in 2005 and 2006 because of these night setbacks and other energy saving functions. We currently use a Siemens Apogee building management system, but there are many building management systems can help you utilize these features to help you monitor, program, and tighten the controls on all air handling units and variable air volume boxes serving critical and non-critical areas. This is significant for energy savings capability. Next slide, please. So utilizing building management system, we work at the mandatory outputs without exceeding requirements which would use excessive energy and wear out components. It also prevents drifts below the required range to keep our operating rooms compliant and safe. We have remote digital monitors on all the critical environmental points in the ORs at the Anaheim Hospital. Next slide, please. One more slide. As you can see, these are some of the points that we monitor to help us make sure that we're maintaining a safe environment while taking advantage of energy-saving opportunities. Utilizing all these inputs, we have ranges, alarms, and inputs so that all critical care components are taken care of. And whenever a critical point is an alarm, it notifies the engineer to respond accordingly so that we make sure we're maintaining a compliant, safe environment. Next slide. So taking advantage of night setback and occupancy. So during normal operations, there are very minimal opportunities for energy savings. You maintain within the operating ranges, but you have to maintain your set points and compliance. The opportunities comes during the off shifts when the operating rooms are not in use, as previously mentioned. The Anaheim Hospital utilizes a night setback feature where we adjust the temperature set points, which is setback for energy savings. The adjustment of set points in turns reduces the output needed from the air handlers via mechanical cooling, heating, and CFM. Humidity and pressure sensors in the operating rooms verify that the rooms remain compliant to keep a sterile, safe environment. If emergency cases take place on or during these timeframes, a call would be placed to the engineering department that would disable the night setback feature. This process achieves significant savings, especially during the summer months when mechanical cooling drives energy costs to twice the average monthly budget during the rest of the year. Another feature we're looking at is the occupancy sensors to take advantage of during normal operations. The hospital has received capital funding to implement controls that will allow the same savings that occur during the night setback to take place whenever an operating room is not being used. Although these are minimal at times and opportunity, this could be significant savings if not utilizing the significant air changes in mechanical cooling capacities when a room is not being used. So we're utilizing, by doing analysis and doing training with the staff and education, we're hoping to take advantage of these benefits and ensure proper implementation. With more than 100 operating rooms to account for the New York Presbyterian Hospital, this process implementation would mean significant savings and energy yielding. That's pretty much the end of my point, but I can answer questions at the point for anything revolving controls and automation. Thank you.
Great. Well, thank you to our panelists so far. This is John Jameson, a healthcare and higher education account manager with the Better Buildings Alliance. We're going to our question and answer session here. So we've got a couple questions that have been typed through the chat function. I encourage you again, if you have any questions for Paul, Jeff, or Roberto, please type those into the question field and we'll receive those and read them out loud. The first one here, we got, this is probably for you, Jeff. It says, you talked about reheat in VAV system. Is this for critical humidity control, and is this really required?
I don't think I've ever seen a VAV healthcare facility that didn't include reheat. Two reasons primarily. Because you have a minimum air change requirement, you have a minimum amount of air that you have to deliver to these spaces. And at least for those of us like myself who live in the areas of the United States that have humid summers, you pretty much have to cool the air down at least to 55 degrees or so to dehumidify it in order to stay below your 60% humidity limit in most of the healthcare spaces. So you've got a fixed amount of air that's around 55 degrees Fahrenheit going into these rooms, and typically if you don't have a means to reheat that, sometimes you get complaints that the rooms just get too cold. Also in my climate we have winter, and it's often used as the heating source also. I do know of one or two facilities that have made the decision that infection control is more related to your room cleaning and physical contact, and have set their air changes maybe lower than the code requires, which does save a lot of reheat energy, but I'm certainly not going to recommend that anybody, go below the code mandated air change rates.
Okay, and if you have any follow-up on that question, feel free to type that back in, and we can run that past the panelists again. Next question we have here from Alan Doyle. I sent this to you, Jeff, but I think this might be for Paul or Roberto as well. Feel free to chime in. The question is, for LED procedure lamps in operating rooms, do you have data on surgeon preferences for room set point temperature with halogen and LED lamps?
I can start this off, but I may kick it to Paul at the end of this, being just a nice, kindly person. I only have anecdotal information, and when this was first brought up to me, it was actually John D'Angelo, when he was working for Cleveland Clinic, who brought it up when we were writing the Advanced Energy Design Guide for large hospitals, saying that they had justified it based on the physicians, actually, well, on energy, but also the physicians liked the LED lights, that they had less issues with shadowing when your shoulder covers part of it, because it's a number of discrete light sources instead of all one source. But after they did it, they found that the surgeons set the temperature up several degrees, and some ORs that they had trouble keeping the humidity below 60% at the low temperatures people wanted, that those difficulties went away because of that. I think he mentioned in the 4 to 5 degree temperature range, but maybe, Paul, maybe you have some more data than John had at that time.
I don't have any data on that, and I know that a lot of the ORs are still asking for the temperatures to go below the ASHRAE guidelines, which now CMS is really starting to take a careful look at. And we're hoping that changing out the pattern lights to LED will try and get us some benefits to keep them comfortable at the ASHRAE 68 to 74, AORN 68 to 75 degree marks. And we're real hopeful for that, because we're anticipating even higher energy savings, because as you talked about on the reheat effects, on the chilled loop that also services the ORs, many other places are serviced on that same loop. And so since we're setting it down so cold to achieve the temperatures that they want, we turn around and reheat like crazy everywhere else, so that if we get closer to that 68 to 74 range, we'll be able to increase our chiller output temps, which will save energy, and then use less reheat as a result of that. Lastly, on the LED preference, I also know that the surgeons like those because the focal point, or the depth of field on a LED light, is a lot deeper than a regular halogen light. But I'm assuming that they have some benefit in temperature and comfort as well.
Mm-hmm. Yeah, because I think the LEDs use a heat sink on the back of them, so most of the energy that isn't light, and lights aren't very efficient. I think at the proper frequency, a theoretically perfect light fixture would be about 700 lumens per watt. So the extra heat in an LED is convected off the back of the fixture, whereas in an incandescent, most of it beams out the front of the fixture. It'd actually be an interesting calculation. I guess I could do a mean radiant temperature calculation for equivalent comfort according to ASHRAE 55. I'm kind of geeky enough to think that would be fun.
Okay, just to jump in, we've gotten a number of questions about the presentation, and we will be making the slides available online along with a recording of the webinar and a transcript. So that will be going up on the website in the next week or two. We do have a few more questions here, though. This one's addressed to everyone. And has there been any thought of monitoring air quality in the operating rooms, especially during setbacks? And sample parameters could be particle levels or others?
I don't know of anybody who has done that. I mean, I know when ASHRAE 170 was determining air change rates, for example, in operating rooms, that Farhad did a bunch of research both in numerical calculation and then built a mock-up to test the different air change levels, and that's when the change to 20 was made. But I'm not aware of anybody who's done like particle count testing with 20 air changes versus maybe 3 or 4 or whatever it takes to maintain pressure. I don't know. Have either of you heard of anybody doing that?
I know that one vendor sells a system that measures the particle count, but we don't think that that's really an issue regarding or has a correlation with infection rate. So we're sticking with the existing codes and hitting the 20 air changes per hour. I think the only thing that we exceed is that we filter the ORs with HEPAs instead of the MERV 14.
Yeah, and I think we find that a high percentage of our clients do that go that extra step to HEPA also.
Okay, another question we have here. Have you ever found when implementing LED lights, LED light retrofit in surgery that there was an increase in reheat energy to maintain reheat?
I have not, but I could. I mean, I could imagine it happening if they want the OR relatively warm.
Yeah, I can't see that happening just because they do want it cold the majority of the time. There are very few cases where they want them warm, and it normally involves infants.
Okay. Have one here from Dave Angelotti. Is there any work being conducted utilizing particle counts in TVOC as it relates to demand control ventilation? That sounds similar to the last question we had.
I'm not aware of anything related to demand control ventilation. No, I'm not aware of anybody who's doing an ASHRAE research project or anything of that sort related to that.
I know that I wanted to look into the monitoring systems for the areas that Jeff spoke about to do it on a demand basis with CO2 as your guide point, so long as codes would allow us to go below the minimums. And a lot of those systems sample not only the CO2 but also the VOCs and the particulates. I heard one gentleman from UCLA Berkeley who said that he's cut his energy costs in his laboratory by 60%, and he utilizes that kind of ventilation control, and that it does in fact work. Had a spike in VOCs and found out that one person was wiping down the lab tables with isopropyl alcohol, and they got a spike every day when they did it.
Yeah, and I know ASHRAE has several presentations about that type of system that are, I think they can be purchased for like $15 or $20 a crack. Gordon Sharp is a very good speaker on that topic. Yeah, but I hadn't heard of anybody extending it to where you could also pick up VOCs for things like a conference room and so forth. We've mostly just seen the CO2, which is really being used as a people counter, not as really a contaminant measuring device.
Okay. And next, we have Asesh. I believe you had a question that you wanted to ask via the phone, so I can go ahead and unmute you now if you're ready. Just go ahead and speak when you're ready. Are you there, Asesh? Okay. Asesh, let me know once you're ready, and then we can try this again. Next question we had, and I think Paul and Roberto, this might be in your wheelhouse, but how have surgery staff responded to the idea of indicators telling them that ventilation system is set back while they're working?
So unfortunately, it all depends on the surgeon. But the reality is, as long as you've conducted education and they're aware of the environment, I haven't had, for the most part, I haven't had an issue with that. But like I said, it's all about maintaining communication and knowing what the reason is behind the place. And the reality is, for the most part, at this point, right, we're only taking advantage of the nighttime at this opportunity, so only emergency cases, and that's understandable that they would have to make a phone call. Right now, we're kind of trying to do the buy-in just like they previously mentioned it with the other, because of the significant for us.
Yeah, and as far as Cleveland Clinic's involved, we haven't implemented the setback with it yet. We're just putting the prototypes out there to get their buy-in. When we showed the surgical executive committee the actual user interface, they really liked the idea of being able to see those variables real time and have them actually coordinate or correspond with the exact readings that the building automation system has as well.
Yeah, I was really happy, Paul, that you talked, about how to get buy-in for that, because that's probably one of the biggest problems we see is that a lot of the facilities we work for are so afraid that they'll accidentally do a procedure with it at a much lower air change that they just say no. Just, really we can think up all the energy-saving ideas we want, but if you don't have a plan to sell it to management and the surgical staff, it doesn't amount to anything.
No, and like I mentioned, as we got into it, it became more of a, wow, this is not just an energy-saving thing, but this will improve the quality of the air and the actual physical conditions as they're doing surgery, not in real time, not a year later with a balance report or anything like that.
To piggyback on that, when you utilize these systems, you can also track and monitor and record. So whenever any data is asked for, you can present at any given time for any given day. So whenever a case comes up when somebody says an incident occurred, might be referred to, well, how was the environment in the OR? You can state that it was within temperature guidelines, within humidity guidelines, and within pressure guidelines to eliminate those factors.
That's exactly right. Being able to pin those variables and be able to look up the date and the OR and the time is very helpful, because trying to pour through the data otherwise is very difficult.
Okay. Asesh, we can try this one more time. Try and unmute you here and see if we can get your question in. Asesh, are you there? Okay. Yeah, I got your message, but we can't hear you on the phone line. So if you wouldn't mind just typing it in, we can read it out loud. In the meantime, we've got another one here for Jeff. This one says, are there any studies or research pertaining to air quality comparisons for ASHRAE 170 Addendum N, accepting the sum of spaces versus multiple spaces? Generally, these two methods deliver significantly different results for OA requirements at the AHU.
And could you repeat the first few words after addendum N?
Yeah. Comparisons for ASHRAE 170 addendum N, accepting the sum of spaces versus multi-space formula.
Yeah, and I think that was originally accepted as, what's the right word, an interpretation, in response to an interpretation request. I know ASHRAE has done some research about I'm a little older generation. I still think of it as the multiple spaces equation, and Dennis Stanke always corrects me, but that their math works out, that in a space that is taking different spots in a building and just mixing it, bringing it in at the air handler and so forth, does result in the rooms that are being, I'll call it, underventilated per the 62.1 procedure, do show up as being underventilated. The hard part about it is nobody can solve that 62.1 math. And it's so much simpler designing the system by the outside air method where you add it up and bring it in at the thing. I don't disagree with the 62.1 math. I just think nobody can solve it. And if you take a very conservative approach, you tend to end up with buildings that are 100% outside air or close to it. It's been a real conundrum in our industry because it's theoretically the right way to go, but it's extremely complicated. So there is some research showing that it's correct, though, that we should be doing it that way. Whether it shows that anybody is going to be less healthy, you know, a lot of the air change rates that are in the literature are kind of educated guesses more so than being backed up by some research.
Okay. I'm going to go ahead and read Asesh's question out loud here that he had before, and that was, at the VA hospital, they normally don't allow setbacks in the OR suites, and does ASHRAE accept this concept for ORs? It sounds like the answer is yes.
Well, I mean, VA is the federal government, so they don't necessarily have to comply with all the ASHRAE standards, but I guess I thought the newer VA guidelines actually did ask for setback in operating rooms. Because I remember reading through the more recent energy guidelines for them, and I thought they were very well written. I know there was a time when VA did not permit that, but I thought that had changed.
Okay. Asesh, if you have a response to that, feel free to type it in, and we can run that back past Jeff. Here's a good question for Roberto and Paul. It's how much selling and what kind of information do you provide to infection control staff?
Well, like I given in my presentation, basically we're telling them that the work to put the setbacks in place actually is improving our ability to maintain the required pressurization and air exchange rates all the time, and that what we had been doing in the past with inexpensive temperature and humidity monitors in the room that were likely inaccurate and not calibrated and not corresponding with the building automation system caused us problems. Letting them know that the doors are being held open after hours because now we're really paying attention to the pressure monitors, and that the air exchange rates on some of the ORs are set once a year, and that we don't have the ability to look back on them, and that with this project we will be upgrading all of those measuring devices and having the ability to control the air exchange rate from the building automation system and make sure that it's 100% right 100% of the time. I think that went a long way to having them endorse it to the Surgical Executive Committee.
To piggyback on that, the reality is to have the best kept environment, you need all these monitoring devices for real-time scenarios. And if you're going to have all these devices and control features, you might as well take advantage of it. If you don't have this, you can't guarantee at any given time if you're maintaining the proper pressure, maintain proper air exchanges, you're estimating. And when you make the estimates when something goes wrong, you're not going to be able to prove that you've done your due diligence to maintain a safe environment. So like you said, you do need these devices, and if you're going to have them, take advantage of that opportunity for energy savings and maintaining the most safest controlled environment possible.
Yeah, you know, the other thing that they did ask for, and I found hard to get, even though infection rates are supposed to be public information, they had asked originally, well, find other big systems and get their infection rates based on surgical cases before and after. And so I didn't find that being an easy task to do. So we were able to tell them, look, that's just not easy to get, especially trying to get the dates that they started doing the setbacks versus when they weren't doing the setbacks, and was eventually able to get them away from requiring that before they could make a decision.
Okay. Asesh, I saw your response, so you can try this one more time. I'll try and unmute you here.
Can you hear me now?
Yeah,
Yes,
Asesh, is that you?
Oh, okay, yes. Sorry, I think there's a miscommunication I had. I thought at the beginning, one of the speakers did mention that in a VAV system in a OR, and that is why I wrote that thing. We don't have any VAV as such in the OR at all. We have a constant volume system, and only thing we do setback, as you call it, if it is unoccupied, to 50% of that for the volume that we cut it down if it is unoccupied. Other than that, we don't change the volume during any other situation in the status in here.
And that is really the way we see it from most people, that during occupied mode, it always is at the 20 air changes. Sometimes we have VAV to go above that if the cooling load demands it because of the low temperatures they're requesting. But then where the VAV really kicks in is when you go to unoccupied mode and they drop it back to maintain just the pressure control in the room.
Yeah, okay, but you don't use the VAV system as such for controlling the temperature. Hope not, right?
Yeah, really at that point, if you're bringing in 20 air changes and the air's been dehumidified, so it's probably fairly cold air, you know, maybe it's been cooled to 53 degrees or something like that, typically then you may be reheating that air somewhat,
exactly.
Because 20 air changes is a lot.
Yeah, that's exactly what we do normally, reheating it.
Yeah, and some clients we've found prefer really to control the temperature of the air going into the room as opposed to a thermostat on the wall. I kind of like that concept because the surgical team is living in the air that's whatever temperature it is coming off the reheat coil, whereas the thermostat over on the wall is somewhat of a different environment and responds fairly slowly to things that happen quickly in the surgical area. So we're starting to see more clients going toward controlling it directly by the air temperature.
Okay, only thing is that there is always a fight between the people who are doing the operation and the patient. Patient says it's too cold, and the operating people will say, oh, we want more cold. So there is that's why we don't keep it under their control as such on the wall.
Yeah, and I think Paul actually first alerted me to that. I had not heard that CMS was on the warpath about that or anything. I've never heard of it amongst our clients. I've not heard of anybody being criticized for going below 68 degrees Fahrenheit. So I'm kind of interested in checking more into what the whole situation is there.
It seems to be that, this is Roberto, it seems to be it all depends on the actual surveyor, because I've seen both sides of that circle. It depends how familiar they are with the guides, because some of them focus with the actual rating posted in FGI, and then some of them will focus on the asterisk where it says, well, up to the physician's care of discretion. But I've seen that, I've been hearing comments here and there that some have been enforcing that guideline, not on a regular basis, but off and on.
Oh, okay, yeah, that's interesting. Because when I read 170, I think it says that the system I design has to have the capability to bring the room to between 68 and 75 degrees. I don't think it says that you as a facility operator need to control it within that range if you choose not to.
I think what the focus is with the asterisk that says if you're going to focus run, it has to be at the physician's discretion. So they want to see how you're managing that aspect. Are we getting a physician's input on what is our basis on? So I think they really want to see that we're understanding what we're implementing and why.
Okay.
Oh,
Yeah,
okay.
well, go ahead. When CMS came to us and was investigating our data, it was kind of an odd situation. They weren't actually here to do a survey. They were here doing kind of a prototype on checking out air quality and making it part of their survey. So it was kind of a cooperative thing for them to look at our data.
Good. Well, this was a good presentation anyway, and it was a good discussion. Thanks.
Thank you.
Okay. And we're a couple minutes past 3, so thanks everyone for hanging on. We have one more announcement. If you haven't already, we encourage you to register for the Better Building Summit coming up May 27th through 29th. It's here in Washington, D.C. And it's our annual gathering for the Better Building Alliance and Better Buildings Challenge programs. And if you aren't a member of either program, we encourage you to join, or we encourage you to come to the summit, even if you aren't currently a member. If you found this session useful, there'll be many more like it, so you can learn from technology team leads and your peers over those 3 days. So thank you once again, and feel free to follow up with us individually via email if you have more questions. Thank you.
John.
Thank you.